Hello, students. All of you, welcome at this point. Student, so now I'm going to start your class as usual, my dear. Okay, so I can say this is student last question of the study class. So what's the question? Have a look once. Student, a metallic rod is fixed. Student, a metallic rod is fixed, right? Okay. Then beta ji, fixed between two rigid supports. My dear, fixed between to rigid support, right? Find beta thermal stress and thermal strain produced in the rod if it is heated by delta T. Young's modulus of rod is that is what by my dear. Okay, so have a look, everyone. Student, I'll solve this question slowly. Still, I'm waiting because not waiting. You can say just I can say maximum student can connect. Okay. I hope someone already joined. So, okay. Hello, student. Hello, Sagar beta. Okay. So now, beta, just I'm going to start your class here as usual. Right. So, beta ji, I can say for this condition. Okay. Uh, Sagar, why you are writing like defeated Krishna? You have to like beta. You have to write beta Hare Krishna only. Okay, fine. Sagar Bacha, have a look here of these questions, my dear. Yesterday I gave it these questions, right? So now, students, I'm going to start with questions here as usual. Okay. So बच्चा जी, have a look here, everyone. Uh, for solution here, sir. Okay, okay. Delhi. Okay. Okay, बच्चा. Okay, Arvind, beta. Hello. How are you, my dear? Okay, very good. I can say Arvind, they have followed me. I was really very surprised to see motivation of this student. Yes, Arvind, beta. Really, I'm feeling proud on you because you followed me. Actually, beta, due to some reason, yeah, I got delay. But I can say Arvind followed me, sir, when you will start the class as well, as I can say. So now, beta, just give me at least 1 minute. I'll wait 1 to 2 minutes. Hare Krishna, student. Okay, just wait here at least 1 minute, right? So that maximum student can connect. And today class, beta, I'll teach you those concepts here which you will get questions for this week. If anyone done this question, so you can just write your answer in chat box. Except Sagar already answered this question. Okay, okay. Fine, my dear. So come to the point here, everyone. Now, beta, I'll not bore. I'll not wait too much. Now, son, I'm going to start class as usual, my dear. So what's the thing, beta? Mention the question. A metallic rod is fixed between two rigid support, right? So, student, let us suppose I'm considering over here this situation, my dear. So, what is the meaning of absolute expansion of substance? Beta, I can say, beta, for definitions we are considering that is beta fixed. Student, that's student, that's but that is I can say desired beta expansion among the rod. Okay. So beta had we concentrate everyone here on the student. So beta you can write that is rod which is beta metallic rod is fixed between two rigid support. Yes, beta, stay everyone in meeting here. I'll take your class around 8:40, right? And I'll do the question sprints only. I'll do beta only questions there. So beta, this is what compressed here. So will not, I can say easily beta expand. So now student, I'm going to just write expression of beta thermal strain. Student, now here I'm going to write expression of thermal strain. Okay, so this is what, my dear? Simply you can say change in length upon beta g, change in length upon original length. What does mean? You can write. Yes, only question beta. Only question बच्चा जी. Only question बच्चा जी. Now beta delta L beta. This is what natural length upon L बच्चा. Okay. So thermal strain beta you can write like this. Beta this is thermal strain. So beta alpha L into beta delta T. This thing already beta everyone know maybe alpha L delta T upon students 1 plus alpha delta t. You know, beta, why, how? Because it's a beta. Okay, Lilith, good. Okay, happy to see my dear. These all things here already I explained. Beta, here I have written delta L here. So delta L beta formula I wanted to write one more time for everyone. So delta L you can write L into 1 plus alpha delta t, no, it's beta. I can say L only. You can say L2 bacha. What's the delta L here? This is what L times alpha delta t. Yes, beta g. So I can say bacha for this condition, beta I use delta L is what? L alpha delta t bacha, and L2 is what? You can say L1 1 plus alpha delta t. Student, you can feed over there, yeah. Again, I'm writing for everyone so that you can easily understand, my dear. Physics fine for everyone. So this is what it's a what's the thermal stream? Change in length upon original length with the G. So you can write, my dear, this is delta L is what? L alpha delta T beta L times 1 plus alpha delta T. You can see beta this is happy birthday. So finally, beta, I can see that is bacha ji thermal stream. You will get alpha delta t upon 1 plus alpha delta t. What, my dear? 1 plus alpha delta t. Okay, bacha, so this is what you can say. You know, alpha is very small. Students, you can take in consideration alpha is, my dear, very small. Students, if alpha is small here, then beta in that terms you can ignore, my dear. So you can write here thermal strain, which is nothing but alpha into delta t. Thermal strain beta nothing but what you can say, this is alpha into delta t. Okay. Now, bacha, I wanted to calculate your next one. That is what, my dear? Thermal stress, right? So, student, how can we find it? We'll go through everyone. Uh, you can take snapshot, yes, beta, just like a session here. And so, beta reactions regularly. It's a highly required. Will help you another candidate to join the live session because according to your beta, I can say like your reactions. Next candidate watching the video, if they feel comfortable, if you are comfortable, they will definitely join with you. So now, students, here I'm going to use here. I can say this is what Young's modulus. So this is beta I can say thermal strain upon beta is what you can say thermal stress upon beta thermal strain. Young's modulus is basically what you can say stress upon strain. Yes, beta is stress upon strain. Okay. Now bacha party he needs to find thermal stress here. So just beta do cross multiply. Thermal stress is nothing but this is beta g thermal strain into beta g and modulus. And so beta g, what you can say? Young's modulus. So beta here you can write here for thermal stress. This is nothing but what, my dear? Alpha Young's modulus delta t upon beta 1 plus alpha delta t. Yes, beta. This is what? 1 plus alpha delta t. Okay, so what's the answer, beta? Anyone from all of you? What's the answer? Which option is correct here? Thermal strain is this, no? Beta, this is what we can say thermal strain. This is the thermal strain. So alpha delta t, this one. Okay. Beta, this is thermal strain with about alpha into delta t upon bacha. Okay. If we are taking consider if alpha is not small, if alpha is not a small beta, then you can say answer for this is the thermal strain. If alpha is not small bacha, then what you can say this is thermal strain. Okay. Uh, yes, 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 definitely. Yes, yes, just listen me first. Listen me first, bacha. Everyone listen first, bacha ji. I'll give time to write. Don't worry. Listen first, bacha ji, because this is live session for growth, for your growth, improvement in subject knowledge, right? So, beta, I'll give you, bacha, definitely. Yes, beta, I'll give you, bacha. So, alpha is, beta, very small. So, beta, this is the thermal stream, bacha, party, and this is what you can say, my dear, thermal stream. So, beta, Bombay is correct answer here. Sagar Maharaj, Bombay is correct answer. Yes, beta, ji. Bombay is correct answer. Beta, note down fast, everyone here. Note down fast, everyone. Beta, from here, you can start, bacha, ji. Ha, notes compulsory, bacha. Notes, beta, ji, compulsory. Okay, go, Sagar, beta. Very good. Very good, Sagar, beta. Okay. If all of you maintain, then see how many chocolate is here, right? So I'll give it tomorrow. Maintained class notes, just regularly, just chatting, like reaction and like the session. You will get chocolate tomorrow. See, already I brought from market too much. Yes, yes, yes. Highly required. Tomorrow I'll see your notes, then I'll give you chocolate. Tomorrow I'll see your notes, then I'll give you chocolate. Yes. That's why na, I'll give you chocolate. Okay, then for you I'll give you something, beta. Sagar, I'll see your notes. I'll give you I'll give you something different. Beta Sagar, for you applicable some different thing. Beta Sagar, for you applicable some different thing, beta. Don't worry. But I'll give you something. Okay. Yeah, note down fast. Don't waste much time. Don't waste much time. Note down fast, beta. Yes, yeah, I'll give you. I'll give you, beta. Just make your rank, beta. Sagar, beta. That is in advance. Beta, advance here. Rank less than beta Z. I can say 500. I'll give you iPhone. AIR, beta, in advance. You have to secure less than 500. I'll give you iPhone. Don't worry. I'll give you iPhone. 100%. Yes. Hello, beta. Vivek. Yes, like session everyone here. Condition applicable here. Just I can say Lalitesh convey a message to beta. I can see Vivek here. What's the terms and condition for the class? Okay, you didn't write last page. Okay. Lalitesh, note down. Lalitesh, note down. Beta. Don't worry. Okay, actually yesterday was he was absent, na? Yesterday, beta, he was absent. Yeah, don't worry. You can note down fast. Lalitesh, fast, bacha, and Sagar, yeah, just write terms and condition, beta, for Vivek. How he'll get chocolate here, Sagar. Just convey message here. Personally, I can see just write in chat box for just highlight the name of Vivek. What's the rules and regulations to get chocolate? Lalitesh, I hope you have written. Lalitesh, I hope you have written this page. Lalitesh, I hope you have written. No, okay. Actually, yesterday was upset. Now that's why you are taking more time. Okay, Lalitesh, do fast. No, tomorrow I'll take notes first, everyone. Tomorrow I'll take your notes first. Okay, do fast. Uh, Vivek's told if you have we have properly he'll be. हाँ yes बेटा then you have right ना बच्चा. Okay, next page. Next page. Okay. हाँ yes behavior बेटा discipline बेटा maintain. Vivek maintain discipline यार. Literally I can say Sagar said everything. So you have to follow बच्चा because this is life lesson for only growth, improvement in the subject knowledge. That is highly required. बेटा God bless you for reaction बच्चा सागर ललितेश अरविंद बेटा God bless you for reaction यार very good. हाँ reactions बेटा compulsory student. Reactions compulsory बेटा जी. You have just so regularly यार. Okay, I hope done बच्चा. I hope done बेटा जी. Okay, 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 fine. You beta Arvind, should I turn the page? Arvind, yes. Okay, fine. Yes, beta ji, this is the last question here. I mean, beta, this is the last page. I hope done everyone. I hope done everyone. Should I start next question? Just allow me. Should I start beta next question? Okay, fine. Good. Yes, beta. Note down question with me, everyone. Beta, note down questions with me, everyone. Beta ji, J2019. Student J2019. Beta note down fast everyone here. I'll write questions little fast. Students ice at minus 20 degrees Celsius is added to 50 gram of water, 50 gram of water at student plus 40 degrees Celsius. Beta G plus 40 degrees Celsius when when the temperature of the mixture reaches 0 degrees Celsius. Temperature of the mixture reaches 0 degrees Celsius. 0 degrees Celsius. It is found that student. It is. It is found that 20 gram of ice. 20 gram of ice is still unmelted. 20 gram ice is still unmelted. Student unmelted. Full stop. The amount of ice, student, the amount of ice added, the amount we concentrate on class beta everyone, the amount of ice added to the water water was close to. Yes, beta. Beta, we have to find out what is the mass of ice basically, beta. There is some data, beta, which you can take in consideration. Specific heat of water, student. You can take 4.2 joule gram degree Celsius. Student, you can take specific heat of ice, my dear. This is 2.1 joule gram degree Celsius. Now, but here I'll do more question student in the classroom I didn't, or maybe tomorrow I'll not do. But here I'll do questions only here because I in the classroom beta I left multiple variety because of disturbance in the classroom. So here student I'll do your multiple question bacha ji. Beta here I'll do bacha multiple question here. Okay, it is specific heat of ice here. This is 2.1. Now, beta, latent heat of fusion. Beta, this is, you can take 3, 3, 4, 3, 3, 4 joule per gram. 3, 3, 4 joule per gram. Okay, now students, I'm writing options here for this question, my dear. Okay, so option first, student, this is 50 gram. Beta, Bombay 60 gram, Vitaji Canada 100 gram, and last beta daily evergreen that is 40 gram. Okay. No, no, no. Don't do Google anyone. Use your beta. Use your knowledge beta, which I taught you. Will get benefit. Literally, all of you will get maximum question from today class notes, which I'll teach today and tomorrow. You will get all question as it is, right? So that is the advantage of this live session. You will enjoy it. Literally, will get very much advantage here. Okay. So now here I'm going to before you told a question, he told sir. No, 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 not applicable, Sagar. That's when I didn't respond it. Sagar, you also know, till now I didn't respond it to anyone, right? Because I'm looking those candidate who answered the question. Once I'll finish, write something on notes, then I can see, yeah, just I'm writing question, how can answer me? Impossible, right? So I'll give some time, bacha. Just put some time and for the students, everyone. Okay, fine. So now students, I'm going to start bacha ji questions. Time at least, yeah, you can take a minimum 60 seconds. Minimum 60 seconds time applicable students. Minimum 60 seconds here time applicable. It's highly required. No one can answer the question before 60 seconds. Yes, at least you have to write something. You have to write the data, think the formula, what questions say. How can answer here before thinking the questions? Right. Okay, beta. Now here I'm going to beta solve this question here. Listen me carefully, everyone. So beta, data I'll take from here. Okay. Now students, beta, have a look solution, everyone. Concentrate, Vivek, Arvind, on class lecture beta only. Okay. So this is the solution here. I can see how much a party. Beta, what's the questions? I'll read here. Ice at minus 20 degrees Celsius is added to 50 gram of water at what beta? This is 40 degrees Celsius. When the temperature of the mixture is reaches 0 degrees Celsius. Okay. So now beta, I'm considering here for this condition m gram of ice. Students, let us suppose initially I'm considering m gram of ice at minus 20 degrees Celsius plus what beta ji? What mentioned 50 gram of water at beta 40 degrees Celsius. 50 gram of water at beta ji 40 degrees Celsius. Yes, beta. So this is I can say beta ji for first condition. This is beta I can say okay, 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 my dear. You also joined. Very good. I'm very happy to see beta. JIT Vinod. Okay. So now bacha, you can say for this condition bacha, what's in questions here? Beta 20 gram ice is what? Still unmelted. 20 gram ice is what, my dear? Still unmelted here. So we can think better like that also. So this is 20 gram of ice plus beta. What you can say? So this is 50 gram plus m minus 20. Beta entire in gram only. Gram of water at beta g 0 degrees Celsius. Simple. So you can say beta heat lost by 50 gram of water and heat gained by this bacha party ice only here. So finally beta I can write students heat student loss heat loss by 50 gram of water is equals to heat gained. Beta this is what you can see. Who will gain the heat here? So you can say m gram of ice, temperature increases, m gram of ice, beta g, temperature increases, plus m minus 20 gram of ice to water, right, beta? Uh, Listen carefully, everyone. Here. I'll just explain everything. But you can take in consideration m gram of ice at minus student 20 degrees Celsius, 50 gram of water at 40 degrees Celsius, 20 gram of ice plus this much of water at 0 degrees Celsius. So heat lost by 50 gram of water and heat gained by what you can say m gram of ice, which is what temperature increases, which is what temperature increases. Okay. So here, bacha, I'll write here what is the heat loss due to water. So this is what, my dear? 50 into beta. What's the specific heat for water? 4.2 beta mentioned in the questions here. Student, this is 4.2 into beta. What's the temperature here? What's the temperature? Beta water at 40 degrees Celsius. Yes, bacha ji. Which is equals to beta. You can take m into what temperature increases. So you can apply what? Ms delta T. You have to apply beta what? Ms delta T here. So here beta what you can say? M into beta what is the specific heat of steam? Mention the questions 2.1 bacha ji. Temperature is what? Initial beta minus 20 here. So what's the change in temperature? Because due to rise in beta temperature, I said in the classroom they can use ms delta T. So this is beta ms delta T. Fine, bacha. Plus, this is what I can say, bacha. But ice is still unmelted here. So, beta, what is latent heat of fusion? Mention in the question, bacha ji. So you can use what ml. Beta here ms delta T, and here, bacha, I'm going to use it. Just I'll write once. So can you can easily understand. ms delta t plus beta जी m into l. Right. So what's my ice mass which is unmelted? M minus beta जी 20 into beta जी 334 into beta जी 334. Okay. Now beta जी have a look everyone here. Further beta we have to solve beta this is what we can say 5 for the 20. So you can see beta this is 2000 here. Into student this is what 4.2 which is equals to beta m into this is beta you can say 21 the 42. So this is m times of 42 plus beta you can say 334m minus the body. You can say beta 4 to the 8 and 32 the 66 6680. Now, bacha, just solve your entire things. Anyone? So 42 into beta, 42 into 2, bacha. What you can say? 84. 84 are one decimal. So you can see this is double zero. Which is beta, you can see this is bacha ji m into 42 plus beta 334 into m 334 into m minus bacha party 6680. Anyone answer me? Finally, answer. Anyone answer me? Anyone answer me, bacha? Anyone answer me finally? Anyone solve? Anyone solve here? What's the answer coming? Anyone? Just tell me. Anyone from all of you? Okay. Respond me here. Anyone from all of you? Sir, solving. Okay, fine. Okay, fine. Okay, fine. Hmm. Do fast, bacha ji. Okay. Okay, Lalit is already answered. Okay, fine. Answer is coming something here. Yes, there is option. Yes, Lalit. I can take it. Your answer consideration here. And approximately, bacha, this is 40 gram. Okay. Okay. Very good. Very good, beta. So, yeah, yes, correct, beta. Correct, yeah. So, beta, I can see your answer is what, my dear? That is options number Delhi. Okay. Correct, Sagar. Yes. Good. All of you, beta. Don't worry. Tomorrow applicable, which I said here. Correct, beta. Got it. हाँ बच्चा जी. Anyone want to just if anyone want to note down solution here, then you can note it. Anyone want to yeah, just note down solution, then you can note it, bachcha party. Otherwise, yeah, I'm going to beta start next questions here. Yes, beta ji. Everyone? Okay. No need. Okay, very good, Sagar. Literally, I can see Sagar. Very good. हाँ बच्चा. Beta, have a look at next question, student. Okay, good, Vivek. You are also literally, I can say, active in today live system बच्चा party. Beta, this is JE बच्चा 2020. JE बच्चा जी 2020. Beta, note down every question with me only. Calorimeter of water. A calorimeter of water equivalent. Water equivalent 20 gram 20 gram contains 20 gram contains beta G 180 gram 180 gram of water at 25 degrees Celsius. बच्चा जी next. m grams of steam, m gram of steam at 100 degrees Celsius is mixed in it till the till the temperature of the temperature of the mixture 31 degrees Celsius. The value of m close to. Already, I did this question in your classroom, right? The value, the value of m is close to. Okay, now is it fine? Ladies, is it fine, Bacha, now? The value of m is close. The value of m is what? Close to beta. You can take what is latent heat of beta vaporization. This is okay. Okay, bacha. Just tell me right here if there is any problem, beta. If you are facing beta Lalit then you can write bacha ji. 540 calorie per gram. Now, students, you can also take specific heat of water. This is students 1 calorie degree Celsius. Now, beta, I'm writing options, so you have to answer me. I can say mass is close to in gram. Student, you can answer me here. Mass is close to right. So beta, this is options. You can take 3.2, 2 bacha ji, 2.6, and last beta ji, that is 4. That is 4. That is 4. Okay, I can say A, America, Bombay, Canada, and Delhi. Okay, anyone, anywhere, anytime, you can watch solution of this question. This questions came in J 2020. Usually, beta, this question why it's more important because of what? Water equivalent. So, student, I can say maximum candidate has a I can say ambiguity. Let not much crystal clear this concept. So, watch this video, watch this session. Definitely, will get clarification. Uh, I can say of these questions. Okay, fine. Now, yeah, I'll do this question little slow and easy for everyone. Okay, now beta, have a look here. Student, everyone attention on the class here. Okay, so beta ji, have a look everyone. What says beta questions? You don't know anything? We have to find a calorimeter of water equivalent 20 gram. As I said in the classroom, my dear, 20 gram here. The simply beta we can add in what? I can say beta mass of water simply, my dear. Right. So here beta, I'll use the concept. Let us suppose initially m gram of C student m gram m gram. What he wrote here, this boy Sagar beta, can you translate beta ji what he wrote? Sagar beta, can you translate here what he wrote this boy? BHAR 45. Huh. M gram of steam m gram of steam at beta जी 100 degrees Celsius. You can take in consideration m gram. So now student m gram of steam beta at 100 degrees Celsius. You can take beta because we used to find basically mass of steam basically, right? Plus beta, as I said here, this is the water equivalent. Simplest way, you can just add beta 180 gram, right? So now students, this is 200 gram beta. This is 180 plus 20 bacha. This is 200 gram water at beta ji 25 degrees Celsius. Listen carefully, everyone. I'm giving you as a short trick. हाँ, yes, now already removed na beta. If I'll get something from somewhere bacha party, so remove it. Don't worry. Yesterday night beta also I can see in the class there are I removed 3%. So already I removed here someone. Don't worry. If I'll get some disturbance here, so myself will do. Beta, this is m gram of steam, 200 gram of water at beta ji 25 degrees Celsius. Right. Now beta, what's the final mixture at what? 31 degrees Celsius. Beta ji, final means you can see beta, entire mixture. Beta, this plus this at what beta? 31 degree Celsius. So do bacha party once here. Because now this is steam. This is what? Entire we have 200 gram water. So basically, I can see water absorb heat. Water absorb heat from what? Steam only. So bit I can write here for consideration, my dear. This is heat absorbed, heat absorbed by the water, which is Q, my dear, ms delta T. बच्चा जी ms delta T. Okay. Beta, what is the mass of water, bacha? Because na heat observed by water from what? Steam, bacha. So what is the mass of water, beta ji? We have already here. This is you can say, bacha ji, 200 gram. Okay. Now, bacha, S, what we can take? One bacha only. Okay, what is the delta T? I know what is the temperature of mixer bacha, which is what 31 degrees Celsius. And what is the initial temperature, my dear? 25 degrees Celsius. So delta T can write beta 31 minus 25, which is nothing but it's a 6 degrees Celsius. So in that terms, cancel here. So you can say heat observed by water from steam. That is what, my dear? 1200 calorie. Beta, what we can say? 1200 calorie. Okay, Vivek. Wait, beta, I don't know. I'll tell bacha ji. I'll tell beta ji. So this is beta. I hope beta till now clear everyone. Beta, I can say okay, okay. Good beta, Arvind. Now bacha ji. This is the part A beta I can take for consideration. Beta, I can take here. This is the part A which I have done. Now, students, what's the questions here in part B? Just you can tell like that. This is what my dear step one of this question, solution question, beta. Now, beta, ji, you can take for consideration. This is my dear step two for this question. So here you can write beta everything carefully. M gram of steam, m gram of steam at beta ji 100 degrees Celsius. Now, this is what mixed with, you can say, this is m gram of water at 100 degrees Celsius. Now, what's a party? Okay. Wait, Vivek beta, I'll tell you, my dear, don't worry. Now beta system finally at what 31 degrees Celsius. So beta from I can say bacha party I this is steam and this is what water. So first beta we can apply a formula what you can say bacha both are at same temperature, yeah. So this is what phase transformation formula. Phase transformation formula beta. What you can say Q is equals to ml. Q is equals to ml. And here beta what you can apply? This is what because rising temperature. So beta you can say. So this is what my dear Q is equals to ms delta T. This is very easiest way to solve this question, bacha. So now beta I can write here Q is equals to let us suppose you can say Q1. This is what Q2. So beta Q1 what you can write M into L. So what is L here? L already mentioned in the question. L already mentioned in the question 540 beta G. So Q1 you can say 540 M, right? This is what Q1. Now beta G you can see Q2 here, which is MS delta T. M beta how much here? M remains bacha, M only here. Okay, S beta G, what we can say for water, one only beta G. What's the rising temperature here? This is what 100 minus 31st here. 100 minus bacha buddy 31st. How much will you get here? 69 na bacha. How much will you get here? This is what 69. Yes, beta G. Beta we add here entire things because so student you can just take in consideration heat supplied, which is Q1 plus Q2 here, which is nothing but 609 M. Beta, what you can see 609 M. Okay, okay. Wait, bacha. I'll tell you, bacha ji. I'll tell you, bacha ji. Okay. So now, beta, at equilibrium, student at equilibrium, what you can say, heat absorbed is equals to heat supplied. So beta, what is heat observed here? Already be calculated. Beta, already be calculated. That is what beta G 1200 is equals to bacha G heat supplied here. How much? 609 M bacha party. So anyone just say me here what's the answer coming with a M? What is answer coming? Anyone? Anyone from all of you? Delta T is 6. No, no, sir. Okay. Sir, I also think it's 2. Okay, ZIT Vinod, very good. Correct, beta. M a beta, I can take 2 here. M bacha, what I can take, that is what 2 here. So this is, students, I can say answer for this question. Beta ji, what can I say? Answer for this question. Okay, very good. I'm very happy to share. Okay, Lalitesh, Vivek, JIT, and I can say one more candidate. That is Sagar Maharaj. Okay, beta. Have a look here. Everyone, next question, my dear. Everyone here, have a look. Next question, bacha party. Okay. Uh, so, beta, what's the question here? Everyone, note down question with me here. Uh, lead, lead, lead ball at 25 degrees Celsius, 25 degrees Celsius is dropped from a, this question I did already in your classroom, from a height of 2 kilometer. It is heated, it is heated due to air. It is heated due to air resistance and 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 it is assumed that and is it is assumed that all of its all of its kinetic all of its kinetic energy is used in increasing the temperature of wall. If specific heat of lead is to 1 to 6 joule kilogram degree Celsius. Find the final temperature. Find the final temperature of ball. Beta, it's a subjective question of a party. So do everyone. Okay. Anyone? Sir Vivek went to it. Okay. Literally, Sagar, I'll talk to you tomorrow. Very good. Very good. Sagar, beta. Okay. Now, beta, I'm going to solve this question. Sagar, can you see it? Hmm. Okay. Okay. I got answer from Sagar and Laliti, same answer. Okay. Okay. Very good. I'm going to solve, my dear, this question. Very happy to share. Okay. Fine. So, beta, yeah, beta, in step one here, we'll go beta slowly. We'll go, my dear, slowly. Okay, very easy. Yes, yes, correct, correct, Sagar beta. I'm proud of you, my dear. Very happy to see your confidence. Yes, beta, literally, I'm very happy to see beta your confidence, beta ji. Okay, you also JIT Vinod. Okay, Bacha ji, I can say, beta, if there is no resistance, then velocity of ball on reaching the ground, beta, you just drop, now, bacha, from here. So you can say, bacha, zero. This is height s here. So this velocity attained by the block just before hitting the floor. What we can say if there is no resistance with party, V is what root of 2gs. Now dear, okay. So here students, I'll write V is equals to root of 2 into 10 beta 2 kilometer here. So this is what we can say 2000 meter bacha. So beta how much will you get here? 2 to the 4. Beta, this is what I can say, bacha ji, 200 meter per second. I hope all of you got same answer. Now, students, I can say for step two, bacha party. Kinetic energy of the ball, beta, we can find here. Kinetic energy of the ball. Kinetic energy of ball is this is half mv square. Half bacha party. Mass beta, they didn't mention here, so don't worry. You can write beta mass as usual only. And beta, this is what 20 December 400 here. So I can say, bacha, this is the condition. beta cancel here. So we can write beta finally, my dear, over here, mgs equals to q. Okay, this is beta 2 into 10 to the power 4 times of m joule, right? Okay. Only I can say four students available remaining. Who is the beta? Just be careful, beta. Sagar, for tomorrow chocolate time. Sagar, beta, just be careful. How many present in the class now? Yes, because you are the coordinator of this batch. By now onwards, I'll consider you as a coordinator of this batch, beta. 2 into 10 to the power 4 millijoule here. Just you have to be careful who is present in the classroom and who is not. Okay. Now, beta, I wanted to find here in the step third, beta ji. In step third, beta ji, right? This is all kinetic energy absorbed by the ball as a heat, beta. So simply you can write kinetic energy is equals to beta ji ms delta t. What's the energy we got here? 2 into 10 to the power 4 into beta ji m. M bacha, and what is S? What is specific heat mentioned here? 126. 126 bacha ji. And what's the delta T? And we used to find delta T basically, na? What we used to find here? Find the final temperature. Yes, delta T R. You can say beta ji this m finish here. So what you can write with a delta T? This is 2 into 10 to the power 4 beta g 126. So beta just two time cancel here. You can say this is 10,000 by 63. How much coming here? Temperature in degrees Celsius. Let's say, then careful, beta. Beta, be careful, bacha. Just be careful, bacha. Party, Arvind, because all of you watching here, I'm just busy with in the class. So yes, beta. Yes. Correct. Then beta, you noted, beta. You note, beta. You note down. So delta T beta, how much coming here in degrees Celsius? Anyone solve further here? If you have a beta, just idea to just solve. Okay, बच्चा जी. Okay, okay, fine. So delta T beta, how much coming here from anyone from all of you? Anyone from all of you here? Hmm. Okay. Anyone from all of you here? Just answer me. Beta, this is coming here 158. Correct, Sagar beta. Correct, Sagar beta. Correct, beta ji. Very good. 158.7 degrees Celsius. Yes, beta. Me answer remains same here. Good. Very happy to see bacha party. Very happy to see my dear everyone. Okay, beta. Next question here. Beta, everyone do next question here. Yes, I can say currently present in the classroom. Okay, yes, but if we use MG is supposed to. No, that is wrong, beta. This is correct process. This that is wrong, bacha. This is correct process, bacha. There is a little change, bacha. Doubt? No. Beta, this is the right way to do this question. Beta, unfortunately, you can say sometime we'll get answer. But method two, beta, I was using that one also. But no, particle gain energy here, velocity. So particle will convert that energy in terms of kinetic energy. Then we can apply bacha. Then this answer will get your correct answer. Then bacha ji will get correct answer here only. Yes, beta ji. I hope you got it. Sir, can you show solution? Yes. Why not, beta? Beta, I'll repeat again here. In step one, bacha, I used beta, I can say concept of kinematics. V is equals to root of 2gh, right? So beta, I'll get velocity here. Then bacha, because particle get velocity, so this velocity are, I can say that is what in terms of beta, you can say potential energy here, right? So beta, this velocity here, first we have to find kinetic energy. Beta, after that beta, you can apply kinetic energy is equals to ms delta t, because mgh is what we can say potential energy. Mgh beta, what we can say, this is the basically potential energy. I hope it got it, bacha ji. Okay, okay, fine. Yes, beta ji. I hope all of you done. Okay, Sagar done with your body. Can you show next page solution? Or already have written? I'm looking beta your reply. Is it fine? Should I change the paper? Okay, fine. Okay, fine, beta ji. Just have a look everyone here. Next question here. Yes, beta ji. Plate heated question already I did na bacha in the classroom. Means here, not in the classroom. Bacha ji, plate heated question bacha already I did na yaar in your classroom. I can see in live during live session. I hope all of you remember here these questions, right? Okay. Come बच्चे पार्टी next question here. Okay बच्चा next question बेटा जी. Copper. It's a good question again बच्चा I can see. No, this is copper. A copper cube. A copper cube of mass from here student. A copper cube. Copper cube of mass 200 gram slides. It's a literally good question, Arvind Bacha. So we beta pay attention here only, Bacha. A copper cube of mass 200 gram slides down, slides down on a rough inclined plane on a it is a rough inclined inclined plane rough inclined plane of inclination inclination 37 degrees Celsius at constant speed, my dear. At constant speed, right? Assume, assume that, assume that no any loss. Assume that, assume that any loss in mechanical energy, mechanical energy goes into no beta, Baria, you're not allowed beta. Punctual candidate only allowed beta. You MSc beta both are not allowed beta. Assume that any loss, assume that any loss in mechanical energy goes into the block as as thermal energy as thermal energy. Find the find the increases find the increases in temperature of block as it slides down through 60 through 60 through 60 centimeter. Beta G, right? Specific heat of beta copper 420 joule kilogram Kelvin. Yes, beta. Literally, beta. Very good question here. So be attentive, beta. Everyone here only. Uh, Now, beta, have a look. Everyone, solution of this question. I'll repeat question once here. A copper cube of mass 200 gram slides down on a rough rough inclined plane of inclination 37 degree at a constant speed. So you can say acceleration zero. Assume that assume that no any loss here. There is something which assume that no any loss in mechanical energy goes into block as a thermal energy. Find find the increases in temperature of the block. Find whether the increases temperature of the block. Okay, attention everyone here only here. My dear, it's literally a very good question, student. Okay, so student, I'll go now. I'm going to solve this question step by step. So this is first step. What you can say, block slides at a constant speed. So beta, what you can say, friction on the block exactly balance the gravitational pull on it. That is what mg sin theta beta. Student, what I'm telling here, I can say, sir, this is the block, right? Students, m is the what, my dear? You can take m as the mass of the you can take bacha in last I'll replace bacha mass initially beta ji I'm considering this is m only, right? Bacha ji, uh, this is what angle is beta 37 degree, mention my dear in the question. Now students, I can say this is beta ji mg. This is, you can say, Bachchaji, remains 37 degree. So this is mg cos theta, my dear. This is what, Betaji? mg sin theta, beta. Okay. According to questions, student, what mention speed is equals to constant. Then what you can think? You can say, sir, acceleration will be zero. Acceleration will be zero. Okay, if acceleration will be zero beta, then what you can say, sir, if particle, because this is what you can beta think like that, mg sine theta is nothing, it's what driving force. So you can tell bacha, the system remains in equilibrium. If system remains in equilibrium, then you can say mg sine theta what acting in downward direction. Now, Bachaji, I can say, beta, Arvind, pay attention on learning, beta. Literally, you are doing very good job, beta, during live session, beta. You are not doing too much in class, but here you are doing, beta, very good. Yes, bacha. Now, beta, I can say, bacha ji, for this condition, you can write, my dear. So this is what? Direction of a friction force. Students, you can say, because already mentioned there, rough surfaces. So here, beta, you can write friction force. Now you can say, sir, system remains in equilibrium. System beta remains in equilibrium, right? But if system remains equilibrium, if system beta remains in equilibrium, then what you can say simply, bacha? You can say simply, bacha ji, sir, friction force is nothing. Students, you can say simply, sir, friction force is equals to definitely mg sine theta because system remains at rest. So, what is the meaning of beta system is in equilibrium? Net force is balanced here. That is beta the meaning of equilibrium, my dear. So, friction is equals to what beta? Friction force is equals to mg sine theta. Okay, so beta here here first I'll find what is the student friction force. So mg beta, you can say bacha, this is what? Beta is 200. Now beta I'm going to convert in kilogram, my dear. So this is what, my dear? 200 into 10 to the power minus 3. Okay, g beta, here I'm considering here 10. I'll see what's the option. Now, dear 10 years, sine 37, all of you remember. Otherwise, I'm writing here, I can see from concept of beta, uh, beta ji, I can see from concept of bacha, I can say bacha ji, concept of beta, I can say mg triangle, bacha ji, concept of beta, I can say mg triangle beta ji, right, my dear? So, this is my barrier. This is should you can see this is 37 degree. So this is 3, this is 4, this is 5 beta. Here you can write sine 37, which is equals to, my dear, 3 by 5. Sine 37, my dear, what you can write? 3 by 5. So you can say beta this is what? 5 to the 10. Beta 2 2s are 4, 4 3s are 12. Right, 12 beta, and this is what? 10 to the power minus 2 beta g, because minus 3 plus 2 here, so minus 1. So you can write beta g finally for friction force. You can write, my dear, for friction force. What was your party? Beta g, you can write, beta, you can write, my dear, from beta g, that is beta friction force. Beta G, you can write, my dear, friction force, which is equals to 1.2 Newton. You can write, beta G, from bacha ji, this is what? 1.2 Newton beta. So finally we got answer of friction force, which is what? Acting on the block. System remains in equilibrium. System remains in equilibrium. Okay. Now beta, student, I finished step 1 for this question here. Listen to me carefully, everyone. It's literally very good question here. So now, student, I'm going to just discuss the student. That is, I can say, beta is step 2. Betaji step to here at as the block slides. Beta, what's the mention question here? I can say as the block slides, beta, how much down? Slides down, beta. This is 60 centimeter. This is what, my dear? 60 centimeter. Right. So, beta, here you can write here what is work done against friction, beta ji. Here you can write work done. Bacha ji, this is against friction. Work done beta against friction here. So what beta? You can say this is friction force. What, my dear? Friction force into length beta ji. Or you can say distance bacha ji or displacement, whatever you can take any you can tell anything. Friction force beta we already calculated, which is equals to what, my dear? This is 1.2. What's the displacement? Was the 0.60 centimeter. So you can take beta in zero point 0.6 meter here. Zero point 0.6 beta ji meter here. So what is work done bacha ji against friction? This is what, my dear? This is 0.72 joule. Beta, what we can say, my dear? 0.72 jar. Okay. But beta, what we used to find it? We used to find temperature. We used to find what the temperature here. So now, student, I'm going to solve here. That is step 3, bachaji. So what you can say? Nothing here. Work done is equals because this entire work done by the friction will convert in terms of heat, my dear. Okay, so this is beta, what is work done here? What is the work done which already we calculated? 0.72. So we can write, my dear, 0.72, which is equals to bacha. You can say M S delta T. What bacha ji? M S delta T. Okay. Now bacha, S mentioned for this question here. How much beta ji? S beta ji mentioned. How much beta? This is a 420. Beta, how much beta ji? 420, right? Now, because I can say we wish to find delta t, my dear. So you can say delta t is equals to 0.72 mass beta ji 200 gram. Beta ji mass already given, my dear, 200 gram. So we can write beta ji m is equals to zero point 0.2 kilogram. So beta 0.2 bacha party. As beta mentioned in the question bacha, my dear. As beta already mentioned, that is what, my dear? 420 joule kilogram Kelvin here. That's why I have taken mass in kilogram, my dear. So this is what beta I can say, zero point 0.2 into bacha 420 here. So just beta do further calculations, my dear. You can see this is the finish, one decimal over here. So delta T you can write it as 72 by 2 into 4200 bacha. This is you can say beta ji 36 upon beta 4200. So beta ji delta T here, this is what? 18 beta 2100 here. So you can say no further beta not possible here. 18 upon beta 2100 bacha. Answer beta will get in degree Celsius here. So beta I can use calculator here. Bacha ji, I can use calculator. Okay. This is 18 divided by bacha. This is 2100. Okay. So beta, this is coming here. Beta ji, you can say approximately 0.00. This is 857 degrees Celsius. This is bacha ji delta T 0.0085 degrees Celsius. Anyone got answer? Okay, okay. JIT, Lalitesh sir is solving our class. Okay, fine. So, very good, dear Bacha Party, everyone. Now, beta, we'll move here next questions, right? That is, beta, I didn't in classroom, but here I'll do, Bacha. Here I'll do, Bacha. Beta, note down everyone question here. Yes, beta, Vivek Sagar available in the classroom only. Okay, have a look everyone. Questions here. So beta clear. This is beta in the classroom. Just I'm telling you, dear. Basically, there are three standard format of questions. Betaji, very good, very good. Betaji, there are three standard of questions here. Three cases. So beta, I'm not doing those cases which I have done in the classroom, my dear. Right. So Betaji, this is case one. Just I'm writing here. What is the case is three, bacha? So this is case one, my dear. Right. Here you can say what is the questions which you can think for case under case one. Fine, fine. Betaji, supplied, heat supplied, heat supplied, heat supplied, convert into vapor. Find heat supplied, convert into vapor. Yes, Betaji. Right. So, Betaji, what's the question here? Already I solved in the classroom. I'm not going to solve this question over here. Beta, this is what you can take 100 gram ice at Betaji minus 20 degrees Celsius, beta. Okay. Now, student, let us suppose I wanted to convert this entire amount of ice 100 gram vapor, beta ji 100 gram vapor at 150 degrees Celsius. So this question has been already I did. Students, this question here already I did, Bacha ji. Right. So, Bacha Party, we'll go through this here. This question, beta, already I did in the classroom, so I'm not going to solve this question here, my dear. Right. Now, beta, ji, I'm going to solve case number two, Bacha ji, for this question. Right. So, beta, what is case two, Bacha ji? Over here. Okay. Beta, ice plus water mixture. These questions, beta, I'm just calling, beta, Vivek, Sagar, JIT, Lalitesh, Arvind, these five candidates. We concentrate here, bacha. We concentrate here, bacha, because this is a new beta for everyone. So we will not get this question in classroom, right? So attention here only, bacha. What is case 2 beta? Case 2 beta, you can take what? Ice plus water mixture. Ice plus water mixture. Beta, it's very common format here. So beta, listen carefully, beta ji. No, 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 no. Only but highly I take but 845. Maximum bacha 845. Maximum bacha. Yes, 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 yes. SR 0 one beta. Yes, yes. I didn't see you bacha. हाँ बेटा yes 9 o'clock. Yes 9 o'clock बेटा. SR 0 one bacha. ये class बेटा 9 o'clock. Sir, will you teach this in class? No, 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 Sagar. That's why not possible at all. That's why he called the name particular person. Why I call name beta Sagar? Because you will get this question here. 100% bacha party on Saturday in the test bacha. Have a look at question bacha party. So what's the question bacha ji? This is the last question for today's session. The remaining I have the cases, but I'll do tomorrow. Beta, this is you can take bacha ji 100 gram ice at minus 20 degrees Celsius plus 200 gram 200 gram water at 20 degrees Celsius. 200 gram water at beta 20 degrees Celsius. Okay, fine. So beta, this is what we have to find. 840 यार 840 बेटा only मुरली हाँ बेटा 840 only बच्चा okay बेटा 800 gram बच्चा okay so I can say 100 gram ice at minus 20 degrees Celsius I'll mix with what I can say water then you have to find a student for this condition what is I can say after mixture what is the final amount of ice and what is the final amount of water. Okay, so just listen carefully here. This question, it's not tough, but I'll go little slower. You can easily understand. But I know what is the, I can say, culprit. What is the, you can say, major point for this question? Student, if you are getting ice plus water, student, if you are getting beta ice plus water, so try to convert these two components. Means ice is also in same phase at the same temperature, beta z water also in same phase at the same temperature. That is the point, Vacha Party. Again, I'm repeating here. If you are getting ice plus water mixture, then what you have to maintain a student concept behind this, beta G. Ice also at the same temperature and water also at same temperature and both are in same phase. Means you have this is your choice. So ice beta I'll convert in water at 0 degrees Celsius. Student water I'll convert in what? You can say 0 degrees Celsius. That's all. Okay, I hope you got my concern here. I wanted to convert, I can say, convey this message to everyone, my dear. Okay, have a look, everyone, students. So here is no. First, I'll convert it as a 100 gram ice at what 0 degrees Celsius. So, student, there is what? You can say temperature change. If there is a temperature change, bachaji, then you can apply here. I said in the classroom. Delta Q is equals to 20, I said in the class paper delta, if temperature change, then what you can apply? Delta Q is equals to ms delta T. From if didn't mention, then from your side you can take everything. So, bacha, I can say, beta ji, delta Q, bacha, mass beta, how much mentioned? This is what 100 into beta 1 by 2. This is 20. So, beta, this is 10 here. So, you can write this is 1000 calorie. Now, beta, I'm going to convert beta ji. This is 100 gram ice at 0 degree Celsius. Beta ji, 100 gram water at beta ji 0 degree Celsius. So here beta, what you can write? Delta Q is equals to ml. Right, beta buddy? Okay. So now m beta, how much remains? 100 here, and L, I hope all of remember 80 for water, latent heat for fusion. So now beta, what you can say? This is 8,000 calorie. So now, bacha, I can say be finally 100 gram ice you converted in water at 0 degree Celsius. Same beta concept you can apply. This is already in water, but try to keep at the same temperature. That is the logic, my dear. So here you can write beta. This is 20 gram. Sorry, beta, it's 200 gram. 200 gram water at beta g 0 degree Celsius. So which formula you have to apply? Delta Q, delta Q beta. This is the point. Keep in your mind, student. For phase change, student, for phase change, what we have to apply? Delta Q. This is the beta. I can say marble point, my dear. This is beta the marble point. For phase change, what you can apply? Q is equals to ml. For temperature change, bacha, you can apply ms delta T. M bacha, how much? This is 200. The specific heat of water, you can take 1. Delta T beta, this is 20. So what you can say, this is 4,000 calorie. Now, bacha, buddy, have a look here. Beta, at equilibrium condition, in last beta point for this question, means second last point, you can say at equilibrium condition, at Bachaji equilibrium condition. What you can say? Beta, we have a 300 gram. We have 300 gram water at 0 degree Celsius. At beta G, 0 degree Celsius. Right. So beta, here we have to apply the formula here. Q is equals to ml. And here, beta, it's your choice. Either you can say Q1 minus Q2, Q2 minus Q1, heat never will negative. So you can take mod, my dear. Q1, let us suppose. Beta, what is Q1 here? 8,000 plus 1, beta. 9,000 calorie. Right. So, beta, Q1 minus Q2. Beta, this is I'm considering, my dear, Q2 is equals to beta m into L. But here one question, how can you tell, sir, formation will take place? Formation will takes place ice or water. Now, bacha, you have a water at 0 degree Celsius. Now, your water taking heat from water at 0 degree Celsius. Then what you can say, bacha party? You can tell, my dear, sir, we are decreasing temperature. So ice will, I can say, this water will go for fridge. This water will go for fridge. Okay. So, bacha, here you can write, bacha party. Bacha ji, Q1 minus Q2 beta. How much? 8 beta, 9,000 calorie here. So now I'm considering here in kilocalorie. So this is the beta ji 9 kilocalorie. I hope all of you got understood. 900 beta 9 kilocalorie. This is beta minus 4 kilocalorie here. So you can say this is 9 minus 4 beta. I can say mod mass of ice will takes place into LHR party. So this is in kilocalorie. So 9 minus 4, what will get? This is the 5,000 calorie beta. Again, I converted here. So this is what, my dear, mass of ice. And latent heat, I can say for ice beta. That is what, my dear, which is equals to 80. So hit this beta. Just do calculation here. Cancel. So mass of ice beta you will get. Student, A mass of ice you will get, bacha. This is 500 upon 8 beta. This is what gram. This is what gram beta. So we can convert here further here. So beta, how much coming? Anyone answer me, please? This is 500 divided by beta. This is 8 here. So A will get bacha pati. Mass of ice is how much? 62.5 gram. Beta, mass of ice beta finally got, that is 62.5 gram. So, beta, what is remaining? This is, I can say, answer of the question. What is remaining water you have? What is the remaining of water you have? So, simple, bacha, I can tell, my dear. What is water we have, beta? I can say 300 gram at 0 degrees Celsius. Simply, bacha, remaining water you can find mass of water, which is equals to 300 minus beta is 62.5. So what you can write with Chapati finally over here? This is 300, 300 beta what? 62.5. So beta, this is, you can see bacha. Now beta, how much coming here? This is 237. Beta ji 237 point beta ji 5 gram. Beta, this is what you can say answer beta for this question. Okay, student, beta, now time beta over for this class. I'll see beta tomorrow as usual, only practice session. Everyone stay at home, do hard work, regularly following, keep following BK sir. Definitely you will get advantage of this live stream because no, here I can see you are getting more confidence. I can say you are replying everyone regularly. That is a major point. I'm very happy to see everyone better for your enthusiasm, motivation, dedication. Bachaji, what you can say towards physics one, Bachaji. Now, student, I'm going to stop this live session, Bacha. All the very best. I'll see you tomorrow.